Hello everyone, it's September 21st. Alright, this is an easy problem, so let's just get it done with real fast. Given this, reverse the order of characters in each word within a sentence while still preserving white space and initial word order. Okay? Not difficult. So what's the strategy? Well, the strategy is I'm going to split. Okay. And after split, we're going to say for W in the split. And then we do this. And then we join it and return it. Yeah, this shall work. God dang. What the hell is God dang? Okay. So, yeah, that's that. Five, 5, 7. Okay, so we're done with this. Let's do this. Number of times binary string is prefix aligned. You have a y-index binary string of length n, and where all the bits are 0 initially. We will flip all the bits of this binary string. One by one, you're given a y-indexed array flips. Hold on. You're given a one-indexed binary string of length n, where all the bits are 0 initially. We'll flip all the bits of this binary string one by one. You're given a y-indexed integer array flips, where flips I indicates that the bit at index I will be flipped in the ith step. A binary string is prefix aligned if after the ith step all the bits in the inclusive range 1 to I are 1s and all the other bits are 0s. Alright, let's keep reading. All the bits in the inclusive range are 1s, and all the other bits are 0s. Return the number of times the binary string is prefix aligned during the flipping process. Okay, so we first flip the third one, not prefix aligned, and then 2, not prefix aligned. And step 3 is to flip index 4. And then this is prefix aligned, okay? And so entrance is 2. Okay, so we can use the maximum to know how many bits we have. And this is the first, this is the second, this is the third, the fourth step. Now we have a 1. 5 times 10 to the 4th. So you cannot just do it, right? We can work some tricks into this? Let's see. We want to know how many times, and each one can only be flipped once, right? So we just want to know at which point we have from 1 to a certain value all hit, right? That's what we want. That's what we want to know. Then how do we know that? So we start I guess 3, okay? We hit 3, and then we hit 2. So we can find the first time we hit 1, right? The first time we hit 1, and the first time we hit. So once we find the first time we hit 1, we just want to know, have we hit, oh, hold on, let me think again. The first time, so when we hit 1, I want to know what others have been hit already. What data structure should we use for this? Size. If I know the size, when I hit 1, if I know the largest value, so if we keep a heap, right, and we have the largest value so far, and then the first time we hit 1, I want to know the largest value. If the largest value, if 1 is the 4th value, and before we had largest value is 4, right? That means we have hit everything, okay? So that's when we hit 1, we can do this. So what we should do is whatever numbers we hit, right? Whatever numbers we hit, so we hit a value, right? So the ideal is to see if we have everything. Yeah, so like we want to hit a value, and the question is, if we are at the ith step, right, we want to know whether we have all I values in the front. And if the largest, so yeah, so after we hit the current value, we try to find the maximum, right? If the maximum is equal to the length, to the step, then we say we have hit everything. Is that correct? I think it is, because everything is unique. It's a permutation, right? So I say if I'm on the 5th step, and at the 5th step, the largest value is 5, which means we have gone through 5 numbers with 5 being the largest, then it must be 1, 2, 3, 4, 5. So that is a hit. But if it's not 5, the largest value is not 5, it will not be anything smaller than 5, right? Yeah, it won't be smaller than 5, it will just be larger than 5. Like this, you can see large value is 4, largest value is 4, but I'm on the 2nd step, 4, and then 4, so that's the one. So yes, I think that is the solution, which is basically we need a heap. So we're gonna get a heap. So import. Okay. That's all we need, a heap. We're gonna say for I index enumerate flips starting from 1. Okay. How much is step, right? And heap q.heap push heap minus index. I don't call it index, I just call it value. And it's val, right? Rest equals 0. Then we say if, oh, I can use length. So I can use length. So I say if length heap is equal to heap 0, right? Then rest plus equal 1. And now we return rest. Okay. Let's check. 2. And this one is 1. Yep. I think this is the solution. Oh, I could have run some tests. Yep, this is the solution. And check the solution, see if there's anything. So the question, the problem, is essentially asking whether we have encountered all the values from 1 to val, from 1 to step when we are at flips step. We can use the fact that at step, if the largest value we have seen so far is step, then we have visited all the values from 1 to step, because all the steps, all the values, all the vals are unique. Hence, the problem can be solved. Oh, I might not even need to use a heap. Actually, to keep track of the largest value by keeping track of the largest value encountered so far, which means current max equals rest equals 0. Yeah, we don't even need this. Say current max equals maximum current max and val. And then if it equal to current max, heap is not defined. We don't have heap. We don't need this. I can just say I enumerate. We said it's going to be step, right? If step, yeah. So we're solving O(n). Yeah, all we need to do is just keep track of the maximum value, and that's it. Yeah, faster. All right, let's check the discussion. See if there's anything interesting. O(n) space. Yes, O(n) space. Huh. Oh, you accumulate. Oh, wow. Good one-liner. Very good one-liner. I did not know accumulate has this usage. See, you learn something new. Interesting. Accumulate. Ah, it has a function. You can multiply, you can max. Oh, damn. We can use accumulate. To easily obtain the largest value at each so far, right? At each step, and solve the problem in one line. So we say for step current max in accumulate flips max, so enumerate, right? And step is equal to current max, and we sum this thing. My bad. Oh. Reference. Can I go find this one? Manual IP. I wanna do manual IP. Can't find it. Now I'll just copy this. Boolean solution. Probably won't do it in an interview, I guess. Too long. Oh, it's the fastest. Good. All right, that'll be it. I'll see you guys tomorrow then. Adios.